Hello everyone, today let's solve Leetcode 704 binary search, one of the most fundamental concepts in computer science and a problem whose variations are frequently asked in coding interviews. It's also part of my DKodeTree Roots 25 list, which is a beginner-friendly list designed to strengthen the coding fundamentals. Be sure to check it out, it's linked in the description. The problem is that for a given list of numbers which are sorted in ascending order, we have to search for a target in the list, and if it exists in the list, we return its index, and if not, we return -1. Now the easiest way to do this is a simple linear search where we scan through each element in the list one by one and check if it matches the target. However, this gives us a time complexity of O of n, since in the worst case we may have to check each and every element. As the input is sorted, so we can do better. And also the problem mentions that we have to solve it in O of log n time. For this purpose, we will be using binary search. Now binary search is actually a two pointers approach. So we take 2 pointers, left and right. We keep our left pointer at 0th index and the right pointer at the last index. I have noted down the indices as well for clarity. Now here's the key question. Which of the values among these should we look at to eliminate the most elements safely? Should we look at the left value or the right value or something else? If we look at the left value, what we can say? Well, either left is equal to the target, in which case we know that this is the answer, or it can be less than the target. But even then, we only know that this one value isn't the answer. Same with the right value as well. It can be either equal to the target, in which case we have got the answer, or it can be greater than the target. In this case also we can only determine that this one value is not the answer. But now, what if we look at a value in the middle of left and right? That's where things get interesting. If the middle value is equal to the target, that means we have found our result. But if it is less than the target, as the input array is sorted, so anything that comes before this middle value will also be less than the target and can be safely ignored. So in this case, we are easily eliminating half of the array. Now, if the middle value is greater than the target, in that case also, we know for sure that anything to the right of the middle will also be greater than a target. So we can safely ignore them as well. So even if it's greater than a target, still we can safely ignore half of the array. And that's the power of binary search. By looking at the middle element, we can eliminate half of the input in just one step. Now let's dry run through this example to understand better. So our left is at 0 and right is at 8. In this case, we calculate the mid as left plus right by 2. So this becomes 0 plus 8 by 2 is equal to 4. So our mid is at the 4th index. Now we will compare the value at the mid element with the target. So as 3 is less than the target, so we know for sure anything less than 3, that is all the elements coming before 3 will also be less than 5. So we will safely eliminate all these elements. For programmatically eliminating this, we have to move our left pointer to mid plus 1. Now our array in consideration reduces to only this part. So we will again calculate the mid value, and this time left is at 5 and right is at 8. So we calculate 5 plus 8 by 2, which comes to 6 on doing integer division. Now our mid is at index 6. Now we will compare the value at index 6 with our target. And as it is greater than the target, so we know anything to the right of 6 will also be greater than the target. So we can safely eliminate everything to the right of 6, including 6 itself. So for this, we have to move our right pointer to mid minus 1. Now our left and right pointers are both at index 5. So our mid will also point to index 5. Now we will again compare the value at mid with our target. And this time it matches. So we have found our target and we can return the index of mid as result. In this case, we found our result. But suppose a case we haven't found it. In that case, we will only continue this process till this condition is true, left less than equal to right. Because once left crosses right, that implies that there are no elements left in consideration. And we can safely return -1. Another important point to note is the calculation of mid value using this formula. This formula will work pretty well in Python because in Python the integers don't overflow. But if you are using any other language, this formula may give you incorrect results at times due to integer overflows. So for this, what we can do is we can just find out the difference between r minus l by 2 and add it to the left index. This will ensure that the mid value does not overflow during calculation. Using this part, what we are doing is, in a number line, we are just finding the difference between two numbers and dividing it by half to get the half of it. Now, to get the exact position of this, we are adding this with the left index. Say on a number line, we have left and right pointers. In this case, r minus l is actually this part. And if we divide it by 2, then we get this section. Now, as our left may not always be at 0, say it's at 7. So to get the value at the mid, we have to add it with the left index. As we know, the time complexity of this approach is O of log n. But how we are getting it? Notice that at each iteration, we are discarding approximately half of the array in consideration. Say initially if we have 16 elements, in one iteration it will get reduced to 8, in the next one it will get reduced to 4, then to 2, and finally 1. See the pattern, this is actually power of 2's. 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Say we go through x iterations. In that case, 2 power x is equal to the total number of elements, which is equal to n. So we can write 2 power x equal to n. And taking log on both sides, it becomes x is equal to log n base 2. This is how we get the time complexity in binary search. Also, as we are not using any extra space, so our space complexity is O of 1. So now let's move to the coding part. So we will take two pointers, left and right, where the left will point to the 0th index and right will point to the last index, that is len of nums minus 1. Now we will run our while loop with the condition left less than equal to right. So once left crosses right, we will come out of the while loop. Next we will calculate our mid pointer. Mid is equal to left plus right divide by 2. In Python, this will not overflow, but for any other language, if you want to avoid the overflow, you can use left plus right minus left divide by 2. Next, we will compare our mid value with the target. If nums of mid is less than target, then we will discard left half of the array and move our left pointer to mid plus 1. And if the nums of mid is greater than target, then we will discard the right half of the array and move our right pointer to mid minus 1. Otherwise, we know that nums of mid is equal to the target. So we'll directly return the index of the mid element. And if we come out of the loop without returning anything, that implies we don't have any element that matches the target. So we return minus 1. Now let's run this and check if it works. We can see that this works fine and runs in log n time complexity. If you found this helpful, hit that like button and subscribe to DKodeTree. Thanks for watching. See you in the next video.